everyone, myself Dr. M. Lakshmi Prasad, working as an Associate Professor in the Department of Data Science in the Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about the confidence interval. So before going to see that, so what should be a parameter? So parameter is nothing but a number which is going to be describe the population statistic. And this statistic should also be a number which is going to be describe the characteristics in the sampling data. Okay, so the parameter is the number which is going to describe the population statistic. So whereas this statistic should be a number which is going to be describe the characteristics in the sampling data. So before that, what should be the inferential statistics? So inferential statistic should be drawn from the conclusion of the data. So in that, what we're going to see is the sample. So what should be the sample here is which is going to be describe the data, and using this sample statistic, we are able to infer the population parameter. So from that, we are able to find it out the estimation and can able to perform the hypothesis testing. So inferential statistics should be drawn from the conclusion of the data. Okay. So from that, we have to take a sample. What should this sample means? Which is going to be describe the data, and so using this sample statistics, we can able to infer the population parameter. That means estimation and hypothesis testing we can able to perform on that. So before seeing this, what should be the first step here is that, so first we have to be perform the collection of the data, and from that collection of the data we have to be perform where we can able to get this. So normally we can able to get this from the raw data. Normally you have to perform so many kind of method for extracting the data. So this raw data, so what the data that is going to be needed for that kind of application, so we have to extract the data. So that should be the data collection. So once that one is done, then we have to be perform the descriptive statistics. So how this descriptive statistics is going to perform here is through make use of graphs and through measures I can able to perform, like considering location and then spread. Okay, so graph should be already know that it should be a collection of vertices and edges, and we can also see different types of graphs like a simple graph, multiple graph, planar graph, like that. Okay, so from this descriptive statistic we have to perform some of the measures, and this measures is going to be subjected to the inferential statistic inference. So from this inference, so we have to be perform two types of procedures, which should be that estimation, and second one is hypothesis testing. So once this one is done, then finally you have to make the decision here. This should be the final step, right? So what is the data we are considering? So that should be extract from the raw data. That data is going to be subject to the descriptive statistics, where we can able to done that through graphs or through measures, and these kind of measures we have to be subject to the statistic inference. From this statistic inference, so we have to perform again two steps like estimation and hypothesis testing in order to make the decision. So what should be the estimation here? So here estimation should be the numerical values assigned to the population parameter using the sample statistic. So normally you have to perform estimation of numerical values. So those values are assigned to the population parameter using the sample statistic. Here the sample mean should be represented as x bar, which is going to estimate the population mean, and sampling variance should be s square, which is going to be estimate the population variance, and sample standard deviation, so that should be represented as used to estimate the population standard deviation sigma, and sample proportion is used to estimate the population proportion. Okay, so the sample mean can able to obtain from the population mean, and the sample variance should be represented as square, estimate the population variance on The standard deviation S should also be represented like this, and the population proportion and population like this. So these are the some of the basic notations we have to be considered for the estimation of the confidence interval. And what are the steps you have to perform this estimation? So that should be first one is select the sample and then get acquired information from the sample, calculate the sample statistic, and then assign the values to the population parameter. So in this, very first thing is collect the sample. So we have a raw data. So from this raw data, we have to be collect the data. From this data, we have to extract the sample. Then acquire the required information that is needed from the sample and calculate the sample statistic and assign the values to the population parameter. Our next one is sample statistic is going to be used to estimate the population parameter, which is going to be known as a estimator here. So estimator is the tool, a rule that tells us how this are going to calculate the estimate and then generally expressed as a formula here. Okay, so the sample statistic is going to estimate the population parameter, what we called as the estimator here. So from this estimator, what should be an estimator actually? So it is the rule that going to be tells us how to calculate the estimate and generally expressed in the formulas as the formula here. So these are some of the basic formulas we have to be done here. Mean, so population parameter I'm taking, and now we're going to be estimate the value of statistic and what should be the estimated formula here. So the very first thing, many of them know that mean. So the mean should be represented population parameter as mu, and then estimated should be represented as x bar. So this x bar should be 1 by n into sigma x, and the variance is the other thing that should be sigma square. That should be written it as s square here, and so this one should be treated like this as sigma x squared by minus n 1 by n into sigma x whole square by n minus 1. And next one is proportion. So this proportion is represented as population parameter as p, and p cap should be the estimated value of statistic for that, and the equation is that so x by n. So like this we have to be know all the formulas that is going to be needed for calculating the mean, variance, and then proportion. So there are two types of estimators, like point estimates and then interval estimates. So what is the point estimate and what is the interval estimate, we will see now. So here a single number that is going to be calculated from the sample data. So the resulting the number which is going to be estimate the true value of the corresponding population parameter is considered as the point estimate. So the point estimate is a number that is going to be calculated from the sample data. Normally this one is going to be a resulting number that is going to be used to estimate the true value of the population parameter. Suppose if you want to take another random sample of 10 employees, and mean is going to be obtained from the random sample, and which is going to be different one we have just calculated, right? So the point estimate do not provide information how close the point estimate to the population parameter. So this thing will not be done by the point estimate. And this point estimate do not also consider the sample size and variability of the population from which the sample is going to be taken here. Okay, so these two things should not be provided by the point estimate. So one is that we should not be provide any information. So how close this point estimate to the population parameter, and next one is that how it should also be provide any or consider the sample size and variability of the population here. And next one is point estimate. So in this, the sample size and variability of the population is going to affect the accuracy of the estimate, so that the point estimate is really not that much useful. So this problem can be overcome by using interval estimates. Okay, so two types of estimates, what I said, should be the point and then interval. So in this, the point estimate is going to have so many drawbacks. So since the sample size and then the variability is going to be affect this accuracy of the estimate, so it should not be that much useful here. So this problem can be overcome by the interval estimates. So in point estimate, so this should be a simple sample statistic which is going to be estimate the population parameter. So in this, uh, if I'm going to consider this structure or a graph, so the green, what is going to be the population distribution, and the population parameter is this, and this should be the sample distribution, and this should be the middle of this graph. What I'm going to consider should be this point estimate. And the confidence interval, so that means this the interval is going to be calculated around the sample statistic. So the population interval in between the red mark, what I've shown, so that should be the confidence interval. What should be the point estimate that should be lies in between the two values, lower value and upper value. So that the range or interval should be considered as the confidence interval. So for the example of meaning of 90% of confidence intervals, so for that, so 90% of all possible samples taken from the population is going to produce an interval. So that should include the population parameter, right? And next one should be interval estimate. So it should be consists of range of values. So there's no, what I said, should be in between this upper limit and lower limit. And this population parameter is going to be lie in between certain level of the confidence. So normally this limit of the interval is going to vary from sample to sample, so which is going to be specify the probability, and which should also contain the parameter. So ideally the probability should be high as possible. So the interval estimate should be the range of lower and then upper limit, lower limit and upper limit. So in this should be the interval estimate. So the population parameter is not going to vary this in between lower limit and upper limit, and ideally the probability should be as high as possible. So remember that. So we have to be choose the probability, and this probability is going to be denoted by 1 minus alpha. So typically the value should lies between 0.9 on 0.95 and 0.99. So the probability what we know as the level of the confidence, and alpha is known as the signal significance level. And so the alpha corresponding to the area what should becomes under the curve. And since we're going to take the confidence level into account, so we're going to estimate the interval what should be called as the confidence interval. So like this, we have to be calculate the confidence interval by considering mean, variance, and standard deviation, and the probability of like a level of the confidence, and significant events, and the area of what it should be comes under this. So all this you have to consider and to account, and then you have to estimate the interval what we called as the confidence interval. Suppose how this confidence interval is going to be applied for the larger samples. So the confidence interval of the population mean should be and greater than 30. So the population need not normalize distributed, and sample will be approximately normal. So for this we are going to use this formula here in order to calculate the confidence interval for the large samples. And this is the under type of equation how we're going to calculate the confidence interval of 1 minus alpha, and this alpha value should be lies in between 0.90 and 0.95 and then 0.99. So by considering this diagram, so what will happen, so this is 1 minus alpha value, so that should be 0 point, this one, sorry. And how it should lies between the lower limit value and upper limit value. So the area of water should be the in between the lower limit and upper limit should be the confidence interval value. So here I'm considering Z1 minus alpha, which is known as the critical value of the distribution here. So normally this is going to be taken from standard normal distribution table. So how this critical values is going to be calculated that. So let's take an example. Suppose we are going to have a random sample repair cost for 150 hotel rooms. Gave a mean repair cost of rupees like this, and standard deviation with this. So how we are going to construct the 95% of confidence interval for repairing the cost of population of 2000 hotel rooms. So this is the problem here. Then how we are going to calculate this confidence interval by considering this application like. We're going to have a sample of repairing cost for 150 hotels. So hotel rooms will be 150. So and then mean value they are giving 84.30 and standard deviation. So then how are we going to construct this 95% of the confidence interval for 2000 hotels. So this one you have to be calculated here. So I'll take down this 1 minus alpha value and alpha value and alpha by 2 and finally calculate the z value. So after taking, so if it is so 0.9, so for this 0.1 minus alpha value should be 0.1 and alpha by 2 should be 0.05 and z value should be this based on the critical value how I'm going to be calculated here. So similarly, this confidence interval for the population mean of and greater than 30. So estimate the population mean should be lies in between 90, 95 and 99% of confidence. So for this S value is given and N value is given. So the confidence interval so should be calculated by using these formulas. So I'm substitute those values here and we can able to get as one value as x mean plus or minus 1.48 and second one is 1.76 and next one is 2.31. So like this you can able to estimate this confidence intervals in between this lower limit and upper limit and should middle of the confidence interval can able to calculate here. And confidence level of influence with the interval level we have to be calculated. So how much of width we have to be considered for that we have to be take down this. So x bar plus or minus the width of the interval I'm going to type it as 2 into 1.48 so 2.96 and the 95% width of interval I'm considering it as 1.76 but should be 3.52 and for 99% the width of interval should be 2.2 into 2.31 that should be 4.62. So the margin of error begin should be all the time the z value should be smaller and mean and standard deviation and then n value should be larger for the deviation should be the smaller here. So once you consider these values how the graph will be obtained this. So this should be the lower and this should be the upper limit and this should be the meaning of the confidence interval value. So take the example like survey is going to be conducted. So here the 95% of confidence mean our children spending TV is between this and this per hours per week. So how can we able to calculate the confidence interval? So substitute those values. So in this one equation so that you can able to obtain and the lower and higher upper limit values. So how this confidence interval for the population mean for the second type of problem that should be n less than 30. So the previous one should be n greater than 30 here. So for the smaller populations, so like what is the n value lies in between the less than 30. So here also this standard deviation is going to be known. So which is going to estimate the sigma and we can in order to make the standard distribution like t distribution like this. So for that, the confidence interval for the population mean whose annual is less than 30 is the equation for that. So x bar by plus or minus t into sigma by square root of n. So how this standard deviation t distribution looks like for any kind of applications for like smaller population. So the red bar, what is going to be indicate this standard normal, and green should be the t distribution. So here I can able to consider like 99% of confidence mean weekly sales between this value should be. So for this, how can able to find out this? So simply we can able to substitute these values into the equation, and finally you can also get some lower limit and upper limit value of the confidence interval value. Okay, so that should be the confidence interval. So basics of that and how we're going to calculate the point estimates and then confidence interval values. What are the steps you have to be considered? So for that, so very first thing is the what should be the parameter have to be known. So the parameter is the number which is going to describe the population statistic, and the statistic is going to describe the characteristics of the sample data. And for that, first of all, how to know what should be the inferential statistics. Normally, this one is going to be drawn from the data, and from the data, we're going to extract the sample, which is going to be infer the population parameter like estimation and hypothesis testing. Then the data collection, very first thing, with the first step we have to perform. So it should be extracted from the raw data, and this one is going to be subjected to descriptive statistics, which is going to be conducted through graphs and some measures, and these measures are going to be subject to the statistical inference. So from this statistical inference, we have to be estimate, and then also can also perform the hypothesis testing, and then we have to finally perform the decision making. So the estimation means which is going to be calculate some of the mean values, variance, sigma, standard deviation like this. And the steps in the estimation should be going to select the sample and get the required information from the sample, calculate the sample statistic and assign the value to the population parameter. So here we can able to define the term like estimated, so which is going to estimate the population parameter, and normally this estimated should be a rule which is going to be tells out how we're going to calculate the estimate and generally expressed in the form of formula here. And these are the some of the estimated formulas for finding the mean, variance, and then proportion. So there are two types of statistics like point estimates and interval estimates. So the point estimate should be a number which is going to be calculated from the sample data, and the resulting number which is going to be estimate the true value of the corresponding population parameter. So this point estimates does not provide any kind of information then how close this point estimate is closer to the population parameter, and this point also estimate should have another kind of drawback like it should also be considered the sample size and the variability of the population. So in order to avoid this, we're going to be introduce the concept of interval estimates. So normally the interval estimate should be lies in between the lower limit and upper limit value in between that of the population distribution and then sampling distribution. So for this confidence interval should be the area that lies in between the lower and then upper limit value. Okay, so for this we can able to know the region of lower limit and upper limit value, that should be the point estimate. So in order to calculate this confidence interval, what we're going to be is we have to find out the level of significance and how much a level of significance it should be. We have to be taken into account in between the interval estimate values. So for that, that should be treated as the confidence interval. So now there are two types of cases like where the n should be the greater than 30, that should be the larger population. Yeah, if n less than 30, that should be the small population. So for this the equation we have to be for this confidence interval for the larger population if we are going to know the sigma value. And suppose this is the example. So what I discussed like alpha value I'm calculating by considering I can able to calculate the lower confidence and upper confidence value in between the region I'm going to be calculated here. And this is the other parameter that are going to be considered in the distribution, like critical value. So for this critical value, it should be taken from standard normal distribution table. And suppose this is the problem what I said for the example of confidence interval. And so by taking these values, I'm going to calculate the critical values of this. And this confidence interval of the population, like greater than 30, right? So how able to calculate the low 90%, 95, and 99? So these three ways should be the confidence interval, low, medium, and high. And how can able to calculate the width of the interval? So based on the equation, this we can able to find out the width of interval should be multiplied by 2 here, so that you can able to extract the clearly the regions of this confidence interval. And similarly for this smaller cases, like the population size is less than 30, and this is the equation we have to be followed for that. So in this we have to be know the standard deviation and t-distribution values. So here for this application, I'm going to calculate these values and you can able to see this lower and upper limit value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.